So this is problem number 7, and I already drew the drawing. So first we're going to write out the given. So the mass 1 is 5 kilograms, and the mass 2 is 3 kilograms. And the height from mass 1 to the ground is 4 meters. Okay, so we're looking for the speed of M2 as M1 hits the ground, and the speed will be the same for the two blocks. So first we know that the E initial equals the E final. And we're going to combine the energy for the two blocks. So the potential energy of mass 1 initial plus K of mass 1 initial plus U mass 2 initial plus K mass 2 initial equals U mass 1 final plus K of mass 1 final plus U of mass 1 final, and mass 2 final plus K of mass 2 final. So this one has a potential energy, gravitational potential energy, because it's off the ground. This one does not, so that's 0. And then since it's at rest, neither of them have kinetic energy. And then at the end, mass 2 is going to have a gravitational potential energy. Mass 1 will be on the ground, so it will be 0. And then they both will have kinetic energy. Okay, so we're going to have mass 1 GH equals 1/2 mass 1 V squared plus mass 2 GH plus 1/2 mass 2 V squared. Okay, and then, so we're going to just fill in the masses, the givens, so 5G times 4 equals 1/2 5 V squared plus 3G times 4, because this will be at 4 when this is 0, plus 1/2 mass 2 3 V squared. So we want to get the V on its own because we want to get the velocity. So we're going to bring the other ones over. 5G times 4 minus 3G times 4 equals 1/2 V squared times 3 plus 5. Okay, and then we're going to go 2 times 5G 4 minus 3G 4 over 3 plus 5 equals V squared, and then to get the velocity we'll just take that off and then take the square root of that, and then when you solve that out, the velocity equals 4.43 meters per second. So that's part A. And then for part B, we want to find the maximum height that M2 reaches. And you'd think it would be 4, but since there's a, because that's when this hits the ground, but since there's a kinetic energy still, it'll keep going up. So for that, we're just going to say the energy initial equals energy final. And we're just doing it for mass 2 now, so U initial plus K initial equals U final plus K final. And then since it will have an initial potential, a gravitational potential energy, and an initial kinetic energy, but it won't have a final kinetic energy, so that's 0. This is mgh plus 1/2 mv squared equals mgh, and this is the h that we're looking for. So this is 3g times 4, or actually, let's get the h on its own. So that would be h equals mgh plus 1/2 mv squared over mg. Cross out the m's. Equals, okay, we're going to just keep going over here. Equals g times 4 plus 1/2 4.43 squared, because the answer there is 4.43 over 9.8, and then the answer is 5 meters. And that's number 7.